Hello everyone. In this video, I'll show you how to build a wireless 6-channel RC transmitter and receiver using the nRF24L01 module and Arduino Nano. This project is perfect for controlling RC planes, cars, and boats. Before we begin, if you're new to this channel, make sure to subscribe and turn on the notification bell so you don't miss any upcoming projects. For this build, we require 2 nRF modules, one for the transmitter and one for the receiver. The transmitter module comes with an external antenna for better range. We also need 2 Arduino Nano boards, 2 joystick modules, 2 toggle switches, 2 7805 voltage regulator ICs, and 2 3.3V voltage regulators. Additionally, we'll use a 5mm LED, a few connectors, and 2 Vero boards, one for the transmitter and one for the receiver. An on-off switch, male header pins, First, we take a Vero board and place the 2 joystick modules in position. Then, we mount the Arduino Nano and the nRF module with an antenna onto the board. Once the positioning is done, I've soldered the joystick pins onto the board for a secure connection. Next, we install a switch to turn the power on and off, followed by placing 2 toggle switches on the left and right sides of the board. For stable power regulation, I've attached a 3.3V SMD voltage regulator to the bottom of the Vero board and positioned a 7805 voltage regulator to provide a steady 5V supply for the Arduino Nano. To ensure smooth power delivery, I've also connected a capacitor in parallel with the 5V regulator. After that, and connected the switches, regulator, and capacitor according to the circuit diagram. Finally, I attached a connector to connect the transmitter to the battery, ensuring a stable power supply to the nRF module and the Arduino. Now that the transmitter hardware is ready, let's check the analog readings of the joysticks. Using an Arduino code, we observe the joystick's middle, maximum, and minimum values. Typically, the middle value ranges between 520 to 560. While the maximum is 1023 and the minimum is 0. These values are important for mapping the joystick's analog input to a PWM output for smooth control. Now, let's move to the transmitter code. First, we include the necessary libraries, specifically the RF24 library, which can be installed via the Arduino IDE Library Manager. We then define the communication address for both the transmitter and receiver, ensuring that they share the same address to establish a stable connection. Next, we initialize the radio module using the C and CSN pins. To handle the transmission of multiple channels, we create a structure named Signal, where we store all 6 channel values. We then initialize an instance called Data for this structure. To ensure a clean start, we define a function that resets all channel values to default whenever the transmitter is powered on. Inside the setup function, we configure the nRF module by setting the correct communication channel, disabling auto-acknowledgement, selecting the lowest data rate for stability, and setting it as a transmitter. We also define a border map function, which ensures the joystick values are properly mapped between 0 and 255. Additionally, this function allows us to reverse the signal if needed. In the loop function, we continuously read the joystick and switch inputs, process them, and transmit the data to the receiver. The toggle switch states are read from pins 4 and 3. Once the code is ready, we select the Arduino Nano board, choose the correct processor, and upload the code. Now, let's assemble the receiver. We take another Vero board and position all the necessary components according to the circuit diagram. The receiver setup includes 6 channel output pins, where each channel has 3 terminals, ground, VCC, and a PWM signal pin. Once all the connections are secured, we provide power to check if everything is working correctly. Moving on to the receiver code, we first include the required libraries, including the servo library, which will be used to control servo motors via PWM signals. Next, we define variables to store the PWM pulse width for each channel. These values help in processing the received data before sending signals to the servos. We then create 6 servo objects, 1 for each channel, and assign them to specific Arduino PWM pins. To ensure smooth communication, we define a structure that stores the received signal values, allowing us to handle multiple channels efficiently. We also set up the RF communication address, ensuring it matches the transmitter for proper data exchange. Next, we initialize the radio module with the C and CSN pins and implement a function that resets received data in case of signal loss. This safety feature ensures that if the connection drops, the servos return to a neutral position instead of holding their last received value. Inside the setup function, we attach each servo object to an Arduino PWM pin according to the circuit diagram. We then configure the nRF module to receive data while ensuring stable communication settings. The receive data function checks if new data is available and updates the values accordingly. Within the loop function, we continuously monitor the connection status. If no signal is received for more than 1 second, the system resets the data to prevent unwanted servo movements. Then, we convert the received values into PWM signals. Each value is scaled to match servo signal ranges, ensuring smooth and accurate movements. The received values are then converted into PWM signals, allowing precise and smooth control of the connected servos and ESCs. Additionally, a digital output, such as an LED, is controlled based on the state of channel 5's toggle switch. If channel 5 is activated, pin 2 is set to high, otherwise it remains low. After finalizing the code, we select Arduino Nano, choose the correct processor, select the COM port, and upload the code to the receiver. Now testing the system. I'm using 2 3.7V lithium-ion batteries in series that combine 8 volts to power the transmitter. To verify functionality, I've connected a brushless DC motor, an ESC, and a servo motor to the receiver. First, we connect the ESC to the battery and then connect the signal terminal of the ESC to channel 3 on the receiver. The receiver is powered through the ESC's 5V BC output. Next, I connect a servo motor to channel 1 of the receiver. After powering up the system, I tested all channels, and everything was working properly. If you found this video helpful, don't forget to like, comment, and subscribe to the channel for more exciting electronics and robotics projects. Thank you for watching.